Modern diesel engines are programmed to shut themselves down over a $50 sensor. The engine is not broken. The metal is fine. The software simply decided it should not run. But a man in rural Montana has been running the same diesel since 1981. Not restored, the original, 900,000 miles, never rebuilt. Outlasted 3 body panels, 2 gearboxes, and every piece of electronics the manufacturer bolted to it. He maintains it in a shed with hand tools. No diagnostic port, no dealer software. Just iron, compression, and engineering that was perfected 50 years ago and then quietly abandoned. The diesel engine was one of the most reliable machines humanity ever built. Then something changed. Not the fuel, not the physics, the people making the decisions. This video covers 3 things: what old diesel engineering actually was, the specific systems added to modern diesels that turned a near-indestructible machine into a complexity trap, and the engines from that era that are still running today. There is also a 4th thing: one engine the industry actively worked to discontinue, not because it failed, but because it refused to. We are not naming it until the end. If you own a diesel from before 2005, you may already be sitting on it. Before we go further, do this right now. Look at your dashboard. If you see a gauge or a warning light for diesel exhaust fluid, find the AdBlue filler cap the next time you are near the vehicle. That cap is the entry point for the system that holds your engine hostage. 3 restarts remaining, then 2. The exact mechanism is coming in 3 minutes. Here is what a pre-emissions diesel actually was, and what was removed from every diesel built after it. A mechanical injection pump pushed fuel at pressures high enough to atomize diesel, but low enough to be serviced without specialist equipment. The timing could be adjusted with a wrench. On a modern common rail diesel, injection timing is managed by the engine control unit and requires a manufacturer diagnostic tool to touch. Ownership was deleted. A worn injector on a pre-emissions engine could be bench tested, cleaned, and reinstalled by a competent owner over a weekend. Modern piezoelectric injectors are paired to the engine electronically at the factory. A single failed component requires a full unit replacement at $500 to $800, plus dealer programming time. Repairability was sabotaged. The whole fuel system on an old diesel could be diagnosed by a trained eye. A worn injector smoked. A loose timing chain rattled. A failing lift pump left the engine hard to start when warm. On a modern diesel, none of those symptoms appear in any way you can directly act on. Everything waits for a stored fault code and a connected scanner. Visibility was monetized. Compression ignition without electronic management meant there was almost nothing to fail electronically. No crankshaft position sensor to shut the engine down, no rail pressure sensor to trigger a limp mode, no temperature reading out of range to put the engine into a restricted state. The engine ran because compression and fuel met at the right moment. When that philosophy was replaced, it was not replaced by something more reliable, more profitable. That reliability was not accidental. It was the output of a philosophy that prioritized mechanical redundancy over complexity. The OM617 injection pump delivered consistent fuel metering past 500,000 miles, in taxis, in desert climates. In conditions modern diesel engineers would not claim for their own products. What diesel are you running right now, and how many miles does it have? Drop it in the comments. We want the real world spread. Then the emissions mandates arrived, and one by one, they added systems to the diesel engine that the diesel engine did not ask for. Exhaust gas recirculation came first. The EGR valve pumps already burnt oxygen-depleted exhaust gas back into your clean intake to satisfy a tailpipe target. It is feeding the engine its own waste. The engine is composting itself. Carbon accumulates on the intake valves and inside the EGR valve itself across tens of thousands of miles. The valves choke. Power drops. On a mechanical diesel, those valves stayed clean for the life of the engine. Only air ever passed through them. On a modern diesel with EGR active, that intake is a slow-motion death sentence. Cleaning what the system destroys costs between $500 and $1,500. That repair did not exist before the EGR system did. The system was not added to improve the engine. It was added to hit a government number. The engine pays. The owner writes the check. Then came the part that kills most modern diesels. And it is not the engine. The diesel particulate filter. A ceramic matrix in the exhaust trap soot and burns it off periodically in a process called regeneration. The theory was sound. The practice introduced a failure mode that had never existed in diesel engineering, a filter that blocks permanently if regeneration fails too many times. Replacement cost: $1,500 to $3,000. A $3,000 filter on a truck worth $8,000 to $12,000 tips the financial equation toward disposal rather than repair. The engine is functional. The filter killed the truck. If this sounds like a list of engineering failures, you are missing the point. These are not accidents. They are revenue generators. Each one creates a service event that would not exist without it. The next system does not even pretend to protect the engine. I will show you the kill switch in 60 seconds. After the filter came the selective catalytic reduction system, known as AdBlue in Europe and diesel exhaust fluid in North America. A separate fluid tank, a pump, a dosing injector, a catalyst, and 4 sensors. Each one a failure point that did not exist before 2010. Run the tank low, and a countdown begins on the dashboard. 3 restarts remaining, then 2. You are on a highway at night. The engine is mechanically fine. The metal is fine. The software does not care where you are. It does not care if you make it home. On the final cycle, it will not start again until the system clears. A diesel built in 1980 does not require a second fluid to operate. A diesel built in 2020 does. Now here are the engines that mechanics call the blacklist survivors, the ones that eliminate a specific modern trap entirely by not having it. The Mercedes OM617 kills the software lockout. No engine management unit, no fault codes, no dealer laptop required. A 5-cylinder pre-chambered diesel produced from 1976 to 1991, with documented examples covering over 700,000 miles on the original short block, still working transport across Africa and the Middle East, not restored, running. The Cummins 12-valve kills the emissions hardware cascade. No EGR, no particulate filter, no exhaust fluid system. A mechanical inline-6 produced from 1989 to 1998, with a P7000 injection pump that owners have rebuilt on a kitchen table. Documented examples with over 1 million miles. When something wears, you replace the worn part. When nothing is worn, nothing needs replacing. That sentence cannot be written about any diesel built after 2007. But the Cummins is not the engine the industry tried to make disappear. That one is coming. First, the global survivors that closed off 3 more failure categories entirely. The Perkins 4236 kills the specialist labor dependency, maintained in a shed with standard tools, still running agricultural equipment on 4 continents. The Toyota 1HDFT kills variable geometry turbo fragility, fixed geometry, no electronic actuator, no carbon-stuck vane mechanism. The Land Rover 2-100 TDI kills the common rail pressure trap. Injection at 400 bar rather than 2000. Components that wear slowly and visibly, rather than failing catastrophically without warning. And then there is the engine the industry quietly tried to make disappear. Not through a recall, not through a safety action, through a regulatory reclassification that made it increasingly difficult to register and operate on public roads in multiple markets simultaneously. We will name it now. The International Harvester DT466, a naturally aspirated mechanical inline-6 built from 1971. It uses a wet sleeve cylinder design that allows you to rebuild the entire engine without removing the block from the chassis. You replace the worn sleeves, install new pistons. The engine is functionally new. You never pulled it from the vehicle. It is essentially an infinite machine. And it is a direct threat to the service model that every modern dealership depends on. The engine was never recalled for reliability. It was never discontinued for failure rates. Dealers cannot profit from an engine that does not need them, so the environment around it changed until operating one became increasingly difficult. The engine never failed. The industry failed to tolerate it. It remains in production in commercial variants today. Stop assuming complexity is capability. A diesel with 12 failure points is not a more advanced machine than a diesel with 3. Stop accepting the software lock as a feature. A fault code that prevents a start because a $50 sensor failed is not intelligent engineering. It is a revenue mechanism with a combustion engine attached. Stop calculating repair cost without including the filter, the exhaust fluid, and the EGR interval. A mechanical diesel maintained across 200,000 miles costs a fraction of the same distance on a modern diesel, with its emissions stack intact. The old engineering does not look primitive next to those numbers. It looks correct. Start buying the engineering built to outlast the warranty. The engineering did not fail. The priority did. The old diesels refused to die because they were built before longevity became the wrong commercial priority. The engineering was not abandoned because it failed. It was abandoned because it stopped generating appointments. If this video gave you something the manufacturers would rather you did not know, press the like button and subscribe. The next video covers the specific modern diesel systems that mechanics quietly advise their clients to remove, and what happens to the engine over time if they do not. That video is the one the dealership cannot afford for you to see. It is ready now.